Okay, in this video we are going over the Reteach Chapter 9, which for this year is a blue packet, and this is the review for our upcoming assessment summative on the trig ratios and angles of elevation and depression and solving right triangles. So let's get started on this. These first examples here, let's look. This is basic review of setting up ratios with this given triangle. Now if you kind of look at these ratios here, 9 is 3 times 3, 12 is 3 times 4, and 15 is 3 times 5. So if you take off the 3's, this gives us a 3, 4, 5 Pythagorean triple basic right triangle. So ultimately the ratios of the side lengths are gonna simplify to these. So if we talk about sine, first thing a good rule of thumb when you're first getting started is to always find the hypotenuse and label it. So I'll just put like a red mark on it, and then we have to decide which side is opposite with respect to the reference angle and which side is adjacent. Once the hypotenuse is out of the question, we know where it is. It's always going to be opposite the right angle or the longest side. The side that is part of the reference angle is called the adjacent side. The other side is the opposite side. So if we're using x as our reference angle, which is this angle here, 12 is the adjacent side, and the opposite side is going to be the 9. And then we have the hypotenuse already labeled. So if we want to do sine, sine is opposite over hypotenuse, which gives us opposite 3 over hypotenuse, which is 5. So it simplifies to 3/5. Cosine, adjacent over hypotenuse, the adjacent side, which is 4 over the hypotenuse, which is 5, gives us 4/5. And tangent is opposite over adjacent. Opposite side is 3, adjacent side is 4. So tangent of x simplifies to 3/4. Now if we were wanting to find the angle measure for x, we could do the inverse of either one of these ratios and find the angle measure. In other words, we could do sine minus 1, inverse sine of 3/5, which is 0.6, and that will give us the angle measure that goes with angle x. Or with using the cosine ratio, we could do inverse cosine minus 1, and this is going to give us 0.8. Cosine minus 1 of 0.8 would give us the angle measure that goes with x. Measure angle x. Measure angle x. And we could do the same thing with tangent. Tan minus 1 of 0.75 would give us the measure of angle x. We don't need to do all three of these, but depending on what you're given in the problem, whichever ratio you're given, if you need to look up the sine, whichever pattern you're given, opposite over adjacent or adjacent over hypotenuse or whatever, use the inverse form of that function and you can find the angle that goes with it. The alternate way is to look these decimals up in a trig table, which we have attached to some of our other packets, and find the closest angle measure that would go with these. So we'd be looking for like the closest angle that goes with 0.6000 in the sine column, or 0.8000 in the cosine column, or 0.7500 in the tangent column, and they would all give us a pretty close approximation of the angle. You just have to kind of estimate. Okay, let's move on. Without using a calculator, find the sine, cosine, and tangent of 60 degrees. Now this reviews our special right triangle patterns. They didn't do the 45, 45, 90 though. And remember, with the 45, 45, 90, we've got a 1, 1, radical 2 ratio of the basic side lengths. with a 30, 60, 90. Opposite the 30 is going to be our shortest side, which is our 1. Then we've got a 60 because these two angles have to be complementary with our right angle. We have 1, radical 3, 2 for the ratio of the side lengths in a 30, 60, 90 triangle. So let's look at what we have here. We've got a 60-degree angle. This is the 30. The short side is 1. The medium-sized side is root 3. And the hypotenuse is 2. So we want to do the sine of 60 degrees. So 60 is our reference angle. Again, find the hypotenuse, mark it. The side that makes up the angle, which is our 60-degree angle for this one, is our reference angle, is the adjacent side for this problem. And the other side is the opposite side. And then we already figured out which one the hypotenuse was. So if we need to do sine of 60, we're doing opposite over hypotenuse. We're doing root 3 over 2. If we're doing cosine of 60, here's our reference, we're doing adjacent over hypotenuse, we're doing 1/2. If we're doing tangent of 60, which is opposite over adjacent, we're doing root 3 over 1, which equals root 3. So that's how we would do those. Same thing would work for like the 45, 45, 90. Let's say we were going to do cosine of 45. Okay, using the 45, 45, 90 triangle. Again, here's the hypotenuse. Cosine is adjacent over hypotenuse. We have adjacent side to the, we're using this 45. We use either one. The adjacent side is a 1. Hypotenuse is root 2. So cosine 45 is 1 over root 2, which simplifies to root 2 over 2. If we were going to do sine of 45, it's opposite over hypotenuse. It's the same thing because this is an isosceles triangle, but we get opposite over hypotenuse, 1 over root 2 again. Except we're really using the other one from the opposite side, which simplifies to root 2 over 2. If we're going to be doing tangent of 45, we're doing opposite over adjacent. Tan 45 is going to be 1 over 1, which simplifies to 1. And if you were to check in the trig table in some of our other packets, if you think about what root 2 over 2 is, root 2 is about 1.414, so this is about 707 as a decimal. You can go down the cosine column and you'll see that for 45 degrees, the cosine ratio is about 7.707. Same thing for sine. And then if you go down the tangent column for 45 degrees, you'll find that it's a 1. Okay, so these kind of become shortcuts. If you recognize them, you can actually find the ratios of all the side lengths without having to use any calculations or really any tables. Okay, let's move on. Here we have an example of an angle of elevation problem. They're building a ramp for a water ski, and the question is asking us, what is the length of the vertical drop? So they want us to find out this side. Now they're giving us that the ramp is 11 long. Now in terms of this right triangle, there's always going to be a right triangle. That's the hypotenuse, which makes this the opposite side, and this is adjacent side. So we have hypotenuse, opposite, and adjacent. Now with what we're given in the problem, with 20 being our reference angle, we have an opposite, which is the x, and a hypotenuse. And opposite hypotenuse has to be sine. So this has to be set up as sine 20 is equal to the opposite over the hypotenuse, which is x over 11. And then to solve this, we would multiply both sides by 11, and 11 times the sine of 20, which is 0.342020, is approximately 3.76. So about 3 3/4 feet, 3 feet 9 inches is the length of the drop. Okay, so those were meant to be review problems for some of our past work. Here's another example of an elevation problem. Now, talking about grade, you might have noticed when you've been like going around different places like in mountainous areas, like Maryland, West Virginia, New York, Upper New York State. They'll say like caution, 5% grade next 5 miles or something like that, is kind of like a warning to the trucks. That means that the elevation is going to drop 5 feet for every 100 if it's a 5% grade. If it's like a 10% grade, which would be really steep, it's going to drop 10 feet for every 100 feet. Now we could figure out the angle that goes with that, but that's just kind of how grade works in terms of angles. So the same thing as like an angle of elevation down at the base. So let's see, a survey crew is planning a railroad line which rises to 1,200 feet. So this vertical, I'm going to make a bigger triangle here. So this vertical distance is 1,200, and we're doing feet at a grade of 5%. That means there's a 5% angle of elevation. So if you're topping the hill coming down, you're going to be dropping 5 feet for every 100 until you reach 1,200 feet. They want us to find the length of the railroad line. So they want us to find the hypotenuse. So here we have our right triangle. Here's our reference angle. The x length that we need to solve is the hypotenuse of this triangle. This is the adjacent side, makes up the angle, and the opposite side is 1,200. So we have to use sine for this problem. It's telling us to use sine. We really don't have a choice because we don't have any other measures other than opposite, and we need to find the hypotenuse. So this is going to be sine of 5 is equal to 1,200 over x. To solve it, you multiply both sides by x and then divide by sine of 1,200. So with this type of a problem, let me just kind of talk about this. We got sine of 5 is equal to 1,200 over x. Notice that x is in the denominator on the right hand side here. We're going to multiply both sides by x, and then to get x by itself, divide by sine of 5. So for problems of this type where x is in the denominator on the right hand side, the next you can kind of skip the multiplication of both sides by x. The problem is going to end up being 1,200 divided by sine of 5. Every trig problem that we do where you find a side is going to be of one of two types. It's going to be of this type. If x is in the denominator, then it's going to be the numerator divided by whatever's on the left. If x is in the numerator, let's say we had like tangent of 50 is equal to x over 12 or something like that. If we had a problem like this, to get the value for x, we're going to multiply both sides by 12. So with a problem where x is in the numerator, you're basically going to take your denominator and multiply it times the other side. So a problem like this, we're going to do 12 times tangent of 50. A problem like this with x in the opposite place in the ratio, we're going to be doing the numerator divided by whatever's on the right hand side, which for this one is going to be sine of 5. So every problem that we do solving for sides and triangles is going to be of one of these two types. Okay, let's move on. We want to find this, it says find the sine, cosine, and tangent ratios of all of these. We'll just do this for like one of the angles. So like say for number one, and I don't know if we really need to do all of these. Let's do number 2. And then we'll do number 4, and we'll do number 6. And let's do 3 also. Okay, so, but I'm just going to do it for one angle rather than for both. So for like number 2, we'll pick angle Z. For number 3, we'll pick angle D. And for number 4, we'll use this 25-degree angle that they're giving us. So let's see what we can do. We want to find sine, cosine, and tangent for Z. So let me blow this up a little bit. Where's my thing? Well, we'll just do it like this. Okay, so let's see what we got. Well, let me move it up just a little bit and slide it over. Okay, so let's see what we need to do here. We want to do sine. First thing we need to do is find the hypotenuse. So opposite the right angle, that's our hypotenuse. We're using z as our reference angle, so the other side of the triangle that makes up the angle has to be the adjacent side, and then this side is going to be opposite side. Now if we want to do sine, sine is opposite over hypotenuse. We don't know the opposite side. This could be a Pythagorean theorem problem. I could do 15 squared. We're doing c squared minus b squared equals a squared. So we're doing 15 squared minus 12 squared equals, we'll call it a squared over here. So it's going to be like, well, this is really little z, equals z squared. 15 squared is 225 minus 144 gives us 81, and the square root of 81 is 9. So we can use the we need to use the Pythagorean theorem to find out that the side length of this side is 9. Now generally in trig we try not to use a calculated value, especially with trig ratios, because you're really using decimal approximations. But if this is basically a 3, 4, 5 triangle, 3, 4, 5 Pythagorean triple, 3 times 3, 3 times 4, 3 times 5. I also could have possibly recognized that and known right away that it would have been the 3 times 3, 9 for the side there. But anyway, sine of z is going to be opposite, which is 9, over hypotenuse, which is 15, which simplifies, take the 3 out of both of them to 3/5, or 0.6. Cosine of z is going to be adjacent over hypotenuse. The adjacent side is 12. The hypotenuse is 15. Take 3's out. That gives us 4/5, which is 0.8. Tangent of z is opposite over adjacent. Opposite 9, adjacent 12. 9 over 12. Notice that if once you have the sides labeled, you really don't have to think, because you've already kind of determined where they're at and what they are. You really don't have to think so much. You're just applying the pattern, like SOH, CAH, TOA. We got 9 over 12. 3 times 3 is 9. 3 times 4 is 12. So we get 3/4, which is 0.75. So this is like one on the other page. And let's see. Now if we needed to solve the triangle, which sometimes is something you'll run across on a problem, we've partially solved the triangle because we know what all the side lengths are. We found all these ratios. We only really needed to find one of the ratios to be able to really solve the triangle. Like, let's say, well, we couldn't have used, with what we were given, we were really given an adjacent side and a hypotenuse, so we could have used cosine and found out that the cosine of z was 0.8. Then we could have done cosine minus 1, inverse cosine of 0.8, and found out the angle measure that goes with angle z. Subtracted that from 90, so 90 minus the measure of angle z would be the measure of angle y, and we would have the measure of angle z, and we've got the 90, and then we still would have had to do something about finding the length of the other side, maybe by using one of the other ratios or something like that. But that would have completely solved the triangle. Solving the triangle means find all 3 side lengths. If they're not given to you, you need to calculate them, and find all the angle measures. So once you find one angle, one acute angle, subtract it from 90, you got the other acute angle, and then our other angle is a 90. So this triangle would be considered completely solved once we got the actual numbers that went with the angle measures. Okay, let's look at number 3. So number 3, we have a 5 and a 13, and we need to figure out what this side is. So this is another Pythagorean theorem problem. We're going to do 13 squared minus 5 squared. 13 squared is 169. 5 squared is 25. That gives us 144. And the square root of 144 is 12. So this is 12. So we have a 5, 12, 13. This is another Pythagorean triple that you should basically memorize, because these occur quite a bit in SAT type tests. The 3, 4, 5s they think are a little bit obvious, so you should be expecting 5, 12, and 13s. If you can recognize that you have that ratio going on, you can avoid doing this calculation, and you would know right away that this had to be a 12. But that being said, let's do the sine, cosine, and tangent for angle D. So again, find the hypotenuse, label it. The other side that makes up the angle has to be adjacent, and then 12 for this one is going to be opposite. So we're going to do sine of D. Now sine of D is opposite over hypotenuse. We have 12 over 13. Turn that into a decimal, do inverse sine of whatever 12 divided by 13 is, and that would give us the angle measure that would go with D. Subtract that from 90, we would have the angle measure that went with F, and this triangle would be considered completely solved. They want us to find cosine of D. Cosine of D is adjacent over hypotenuse. We have 5 over 13. Same thing could be done with cosine minus 1 to find the angle measure, in case we weren't given all three of these ratios. And tangent of D is opposite over adjacent. Opposite the D is 12, and adjacent is 5. We get 12 over 5. So this would be like 2.4 as a decimal. Now we could do tangent of 2.4, or tan minus 1 of 2.4, which is 12 divided by 5, and it would give us the angle measure that went with angle D. Subtract that from 90, we got the measure of angle F, and that'd be another way to completely solve the triangle. Now let's move on. Let's look at number 4. Use a scientific calculator and or trig tables to find the lengths of the labeled sides. So I'm just going to set these up, and leave you to use the calculator to finish the problem up. We got 25 degrees. Let's see. Here's our right angle. That means this B must be the hypotenuse. Making up the 25 is A. That's got to be the adjacent side, which means that 3 in this problem is the opposite side. And we want to find the lengths of the labeled sides. So we want to find out what A is. So let's say we're looking for A first. So A is an adjacent side, and we're given an opposite side. Adjacent and opposite goes with tangent. This has to be done as a tangent problem. Tan 25 is equal to the opposite, which is 3, over the adjacent, which is A. Now this is the pattern where A is in the denominator, so to find A, you're basically going to do tangent divided into tan 25 divided into 3. 3 divided by tan 25 is going to be our A. And you can use a trig table, find out what the decimal is that goes with tan 25, and divide it into 3. Or you could use a calculator, just do 3 divided by tan 25, enter, as long as your calculator, be sure it's set for degree mode, and you'll get the value for A. And I would round it, maybe it doesn't say, I'd round it to at least 1 decimal place, if not to the whole number. Let's see, now we also need to find out the length of side B. So finding B is the hypotenuse. We've with 25 we have a opposite with a hypotenuse. That's a sine problem. So we could say sine of 25 is equal to opposite, which is 3, over the hypotenuse, which is B. Here's another one, variable in the denominator. So 3 divided by sine 25 is going to be B. And you could use the calculator or the table and find that one. Let's talk about this width of the river problem here. These are kind of typical problems. There's this thing called indirect measurement that you can do with trigonometry a lot of times. If you kind of think about the right triangles that are involved in it. So they want to measure the length of this river. So what they do is they pick a point, they start at one point on the side, they pick some kind of a landmark on the other side, like a rock or a tree, and then they go some distance off to the side and take a siding of that opposite point and figure out what that angle is, or estimate what that angle is. They know their distance, they know the angle, and then this becomes the opposite side. Now, straight line distance would be hypotenuse. This angle gives us that this is the adjacent side, and then this is the opposite side. So we want to find out what the width of the river is, xy, the width of the river. We'll call that x for this problem. And they found out that they paced off 220 feet, and the angle is 40 degrees. The sighting angle is 40 degrees. So with this being our reference angle, we've got an x involved and a 220 involved. This is an opposite over adjacent, which is a tangent problem. You're going to see that a lot of these type of problems are tangent problems. We would say tangent of 40 is equal to opposite, which is x, over adjacent, which is 220. So here's a pattern where x is in the numerator. This is simply just multiplying both sides by 220. So 220 times the tangent of 40 is going to be x, and the answer is going to be in feet. And that's how wide the river would be in feet. So I could leave that for you to crunch the numbers. Okay, let's move on. So using these triangles in real life, let's see. Okay, now this deals with the solving the triangles, which is finding all the measures of the triangles. So they're giving us this triangle at the right. We don't know what p is. We got a 2 and we have a 5 for the hypotenuse. So 5 squared minus 2 squared is going to, the square root of that is going to be p, because a squared plus b squared is c squared with the Pythagorean theorem. So 25, which is 5 squared, minus 4, which is 2 squared, it gives us 21. The square root of 21 is going to be p. So that's what they're showing over here. So now we got all three sides. What remains to be done to solve the triangle is to find one of these angles. So we kind of have a choice which one we want to do. Again, this is the hypotenuse. Let's use angle R. So R is our reference angle. So opposite, adjacent, hypotenuse. So looks like 2/5 is the easiest one, rather than, we could do the square root using adjacent and hypotenuse, or adjacent and opposite, but easiest numbers might be to use the opposite with the hypotenuse, which would be a sine problem. So we could say sine R is equal to opposite, which is 2, over the hypotenuse, which is 5. 5 goes into 2.4 times, and sine, inverse sine of 0.4 is going to give us the measure of angle R. Now they calculate it out to be 23.6. So angle R is 23.6. This other angle P has to be complementary. Since all of these have to add up to 180 degrees, we've got a 90 already at the right angle. 90 from 180 leaves 90 degrees left for these two. They're complementary. If I do 90 take away 23.6, we get 66.4. And we would consider this triangle completely solved because we have all the angle measures and we have all the side measures. Okay, here's another example. I'm thinking that this deals with a tunnel, the tunnel of Samos, which is there's a good documentary on that. And they basically, they needed to tunnel through a mountain for a water aqueduct, and to make sure that they had the right headings or the right bearings as they basically cut their way in from both sides to meet in the middle, they set up a right triangle. And using this angle, they knew what angle they needed to cut in from this side, and then using this angle, they knew what angle they needed to cut in from this side, and when they met in the middle, they were really, really close. They were only like a couple feet off. And that's what they used to go through the mountain. And this is probably about like 2,500 years ago. But there's a good, I think it's a PBS documentary on the Tunnel of Samos about the mathematics behind it. So I'd encourage you to kind of read through that and maybe check that out if you're interested in it. Okay, let's move on. Okay, so find the length of the other side and the measures of both acute angles. These problems basically have us solve the triangles. Which means find all the parts. So for this one, we'll do number 3. And these others, are similar. You need to at least do one more of these for practice. So we're missing a side over here. This is the hypotenuse. So a squared plus b squared is c squared. 2 squared minus 1 squared is going to be zy squared, the distance from z to y squared. 4 take away 1 is 3. 3 equals zy squared. Zy is going to be square root of 3. Okay, now that we have that, we got the 3 sides. We need to find one of these angles and then subtract it from 90 to find the other angle, and the triangle will be completely solved. So it's our choice which ratio to use. Root 3 might be, a little bit tricky. We got a 1 and a 2. I would do that one, and let's see, let's do x. So if we use x, 1 is the adjacent side, and 2 is the hypotenuse. So we got adjacent hypotenuse, it's cosine. Cosine x equals adjacent, which is 1, over hypotenuse, which is 2. So cosine of x is 1/2. Now if you think back to, let me go back. If you think back to 1/2, sounds familiar as a cosine, as a shortcut. If we went back to the section where we were talking about our special right triangles here, where was that at? Whoops. Right here, the 1/2, right here, cosine. Cosine of 60 is adjacent over hypotenuse. It's 1/2. That's a 60-degree angle. So without calculating, I know that's got to be a 60-degree angle. So that's how this could, kind of save some work if you recognized it. So we know that x is going to be 60 degrees. The measure of angle x is 60. Now if we didn't know that, then we would have to do inverse cosine of 0.5, which is 1/2 as a decimal, and calculate the measure using a table or the calculator, and it would give us 60 degrees for angle x. Now if x is 60, 90 subtract 60 gives us 30. Angle y must be 30. This is a 30, 60, 90 triangle, and the triangle is completely solved. Okay, so with these others, you probably might not. You got the 3 there. It's not a radical 3. So with these others, you just need to basically do the ratio and calculate one of the angles using one of the inverse functions. And then once you have that angle, subtract it from 90. You got the other angle, Pythagorean theorem, to find the missing side. Okay, let's move up. Let's look at number 6. Here they're telling us that the cosine of p is 1/3. Now, cosine is adjacent over hypotenuse. So the ratio of the adjacent side, and here's angle p. So there's a 1:3 ratio of adjacent over hypotenuse in this triangle is what they're telling us. So one way to approach this is to kind of use the ratios. So we have 5, and we're talking about adjacent over hypotenuse. So we don't know, let's call this t. So we've got adjacent over hypotenuse, 5 over t, needs to simplify to 1 over 3. If we cross multiply, we get 15 is equal to t. So we could find out that if cosine ratio is 1/3, and if this is a 5, this other one has to be a 15. Now we could do Pythagorean theorem and find out what this other side is by doing 15 squared minus 5 squared, and that's going to be RQ squared. So using the Pythagorean theorem, let me just switch colors up. We've got the hypotenuse squared, 15 squared, minus one of the sides squared, minus 5 squared, equals RQ squared. That's the other side that we need to find. 225 minus 25 gives us 200. The square root of 200 is RQ squared. Now, as in simplest radical form, 200 is 2 times 100. That's going to be 10 radical 2. So I'm going to use 10 radical 2. But remember, it's square root of 200 in case you need to do calculations. So we got all 3 sides now. Now we have to find the 2 angles that we don't know. It's kind of our choice which one to use. I would use maybe the 5 and the 15. Since cosine p is 1 over 3, 5 over 15 basically is 1 over 3. I basically will do inverse cosine of 0.3333 repeating and find out what the measure of angle P is. Once I know what the measure of angle P is, subtract that from 90, and we've got the measure of angle R. So I'll leave that for you to finish up. Tangent is 1. Now that goes back to our 45, 45, 90 triangle. In a 45, 45, 90, the tangent ratio is 1. That means this must be a 3, and this must be 3 root 2 because we have a 45, 45, 90. If didn't recognize that, we'd have to think about, okay, tangent is opposite over adjacent. So we're using P, opposite over adjacent. Let's call this RQ. So RQ, opposite over adjacent over 3, needs to come out to be 1, which is the same thing as 3 over 3. So 3 times 3 is 9, and so 3 RQs is 9. Divided by 3, RQ is going to be 3. So it could be solved using the ratios that way. We also could have done inverse tangent of 1 in the calculator or on a table and found out that the measure was 45 degrees. Once we know that P is 45 degrees, subtract from 90, we know R has to be 45 degrees, or if we use our original recognizing that it's a 45, 45, 90, we automatically know what all the side lengths are. Just from tangent being 1, recognizing it's a 45, 45, 90, we've got everything in the triangle we need. Okay, let's move on. And that's pretty much all for this part of the packet. So I'd encourage you to review these. On these puzzle problems, I'll do a separate video for those. But basically to kind of talk through them a little bit, if you're a little bit rusty or a little bit hesitant on whether you're using the right ratios or not, this sheet here should help you. They want us to find, like say for number 2, the cosine of A. So A is our reference angle. Cosine is adjacent over hypotenuse. The hypotenuse is 13, adjacent 12. We've got 12 over 13, and T goes with number 2. So down at the bottom of the page, a T would go in every place that there's a number 2. And I think there's only 1 on this one. And if you're doing these correctly, this will spell out something that makes sense as the answer to the question at the top, which is why did the saltine lock itself in the bank vault? So this is good practice to make sure that you are correctly using sine, cosine, and tangent ratios. the who turns out the lights on Halloween are practice problems, finding different side lengths in triangles, and also there are some problems like with ladders, and here's like the guy wire of a tower. All of these, basically you're thinking about the right triangle that's involved. So here we have an angle. This is hypotenuse. This is opposite. This is going to be a sine problem. Here we have the angle. This is opposite. This is adjacent. Here's the hypotenuse. This is a tangent problem. Here we have a ladder leaning against the wall. How high up on the wall does the ladder reach? Here's the hypotenuse. This is an opposite. This one's an adjacent. We have opposite with hypotenuse. This is going to be a sine problem. For this particular one, when you find your answer, you exit off on the bottom. So we'll do one of those. Let's do, let's see, I don't have my calculator with me, so let's see if there's a here. Okay, here's one that's this is a 30, 60, 90 triangle. Let me let me decrease this a little bit. So this is 30, 60, 90 triangle. So that's going to help figure this one out without having to use a calculator. This is going to be the 30. This is the hypotenuse. We need to find out what x is. X is adjacent, and this is opposite. So we have opposite over adjacent. So tan 60 equals opposite, which is 90, over adjacent, which is x. We multiply both sides by x, divide by tan 60. X is going to be 90 divided by tan 60. Now, tan 60, if I quickly sketch a 30, 60, 90 triangle, 1, radical 3, 2, this is the 60. Tan 60 is opposite over hypotenuse, that's root 3 over 2. So I'm dividing 90 by root 3 over 2. So 90 divided by square root of 3 over 2. We're dividing by a fraction, so remember, keep, change, flip. From algebra, you're going to do 90 times 2 divided by root 3. So we get 180 divided by root 3. And I need a calculator to finish it off. But whatever it ends up being, down here at the bottom, you X the box out that goes with the answer that you found. The remaining answers in order will spell out the answer to the question, who turns out the lights on Halloween? Okay, so that's it for this packet. Thank you.